These are solutions for the extension sheet for the quadratics mock exam. First problem. Find the two complex roots of the quadratic. 2x equals 3x squared plus 3. First thing we need to do is make sure that it's in the form blah 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 equals 0, right? Because when you find the roots to a quadratic, you're finding when the function intersects with 0. Okay, so we need to set one of the sides equal to 0. So we're going to move the 2x to the other side by subtracting 2x from both sides. So if we subtract 2x from both sides, we're going to get 0 equals 3x squared minus 2x plus 3. Then to find the roots, especially since they're complex roots, we need to use the quadratic formula. And so on the back of the sheet, there's the quadratic formula. We're going to write it here. X equals negative b plus or minus square root of b squared minus 4ac. Make sure you memorize it correctly or copy it down correctly. Very easy to make that mistake. Divided by 2a. So our b value is negative 2. Our a value is 3, and our c value is 3. So let's copy those in here. So b is going to be, negative b is going to be positive 2, right? Because negative 2. Plus or minus, and b squared would be 4 minus 4, and a is 3, and c is 3. All divided by 2 times a, which would be 2 times 3 is 6. I'll write it up here. So now I have 2, 6 plus or minus, and on the top I have 4 minus 4 times 3 times 3, which is 4 minus 36, which is the square root of negative 32, divided by 6, which is equal to 1/3 plus or minus, and remember I can break up the square root of negative 32. I can break that up into the square root of negative 1 and 32. So that would be I times the square root of 32, right? I could also write I and then put 4 square root of 2, because the square root of 32 could be simplified to 4 square root of 3, or 4 square root of 2. So I'm going to do that. 4 square root of 2 divided by 6. The reason why I can make square root of 32 into 4 square root of 2 is because square root of 32 could be written as 16 times 2, right? And so that would be the square root of 16 times the square root of 2. Square root of 16 is 4. Okay. So here's my solution here. I could cancel out the 4 and 6 and simplify a little bit more and have 2/3 here. So I'm going to put 1/3 plus or minus 2 square root of 2i divided by 3. Okay. So there's my answer. I have two roots. One of them is 1/3 plus blah blah blah, and the other is 1/3 minus blah blah blah. And the second part, 2 square root of 2 divided by 3 times I, is the imaginary part, and together they make a complex root. Demonstrate that multiplying the two complex roots together results in a real number. Okay, so I'm going to take the first complex root, which is that, and I'm going to multiply times the second complex root, which is the conjugate, which just means the imaginary part is the opposite, negative. So I have to do FOIL here, but just to show you that the O and the I, the outer and inner of the FOIL, kind of like cancel each other out, is, look at this. If I multiply the outsides together and the insides together, you can see that I get the exact opposite terms. That's a special thing about the conjugate, and that's why we use it a lot of times, to get rid of those two extra terms in the middle. So since we don't have to do the O and the I, and we'll need to do the F and the L, the first and the last, we'll just do that quickly here. So it's going to be 1/3 squared is the first, and the last is going to be, let's see, negative 2 squared would be 4, square root of 2 squared would be 2, I squared would be negative 1, and 3 squared would be 9. And then 1/3 squared is actually going to be equal to 1/9, right? And the second term is going to be equal to -8 minus -8, so it's actually plus 8 divided by 9. Isn't that weird? Look at that. Even though we multiply together two complex numbers, the resulting answer is a real number because the i's end up canceling each other out. That's another magic thing about complex conjugates is if you multiply uh, um, a complex number times its conjugate, you end up with a real number. You get rid of the complex part of it. And not only that, when I add 1/9 with 8/9, I end up with 9/9, which is 1, right? So not only do we have a real number, it's a very simple number. It's 1. Okay, for the quadratic below, calculate the discriminant in terms of k and simplify. Remember, the discriminant is b squared minus 4ac, okay? And in this case, b squared is k minus 2, and a is 2, and c is 2. So we're going to substitute in k minus 2 for b squared, and this is the discriminant, which is sometimes written with the Greek letter delta. Okay, and this, I'm pretty much done here, but it says to simplify. So if I'm going to simplify, I need to combine like terms. This is 4 times 2 times 2 is 16, right? And then now I can combine the 4 and the minus 16, so I end up with k squared minus 4k minus 12. That's my discriminant. Normally a discriminant is just a number, but in this case they gave us the quadratic with a variable in for b, so we're never going to be able to find it. We're never going to make it equal to a number, right? It's an expression which depends on the value of k. As soon as we figure out what the value of k is, then we know what the discriminant is. When you know what the discriminant is, then you can determine if the quadratic crosses the x-axis twice, or once, or 0 times. Find the value of k for which would define a quadratic function that intersects the x-axis twice. Okay, remember, to intersect the x-axis twice, the discriminant should be a positive number, right? Now, the discriminant is equal to k squared minus 4k minus 12. What number could I put in there and make a positive number? Well, if I just put a pretty big k in there, obviously it would result in a positive number. If I put in like a small positive number, like maybe 1, it wouldn't, because the second term minus 4 would make it negative, and the 1 squared wouldn't be big enough to be negative 12 here. Let's try that out. I'm going to put k equals 1, and I'll show you what happens. If I put k equals 1, I'm going to get 1 squared minus 4 minus 12. I get a negative number, right? So that failed. What if I put in a bigger number, like k equals 100? Well, then I'm going to get, like, 100 squared, which is like 10,000, right? And then I'm going to subtract 400, which is pretty small, and I'm going to subtract 12, which is pretty small. The resulting discriminant is a positive number. So my one value of k, which would make the quadratic function intersect the x-axis twice, is k equals 100. The next thing that's asked is to draw a sign diagram which shows the complete set of values of k that would define quadratic functions that do not intersect the x-axis. So now we're kind of looking for the opposite. We're looking for all the possible discriminants that are negative, right? Because that do not intersect the x-axis. Okay? So now we're going to take our discriminant and we're going to say, okay, I want this discriminant to always be less than 0. Okay? And so I'm going to factor this first, because if I want to find when the discriminant is less than 0, I really need to know when the discriminant is equal to 0, because those are the boundary conditions. Okay? I'm going to factor this. You'll see that when you factor this, it would be k minus 6 and k plus 2, right? Because that would give you negative 6 times 2 would be negative 12. Negative 6k plus 2k equals negative 4k. So that works out perfectly, right? Okay, now we're going to learn how to use a line number to show where are the valid points which make this true. Okay, so first of all, what are the points on the line number which make this exactly equal to 0? Okay, so those values would be 6 and negative 2, right? So I'm going to mark those two values on my line number, and I'm going to mark them with zeros to show that when k is equal to negative 2 or 6, this expression is going to be 0. Okay, and then now I just need to figure out, okay, what values of k make this expression negative? Okay, so to do that, I'm going to try a number here that is pretty easy to plug in, which is 0. I'm going to take the number k equals 0, and I'm going to put it into my expression and see what I get. I'm going to get 0 minus 6, which is negative 6, and positive 2. And if I multiply those together, I get negative 12. So that tells me that the value at k equals 0 of the discriminant is negative. Okay? Now, I know that the discriminant is 0 here. I know the discriminant is 0 here, and I know it's negative right here, right? Now, the question is, what is the value of the discriminant in terms of sign between negative 2 and 6? And the discriminant is a continuous function, which means that, it's not going to change abruptly from like the value of 5 to like 600, right? It's going to gradually change. Okay, so if we know that the discriminant is 0 here and it's 0 here and it's negative here, that means that every single other point in between negative 2 and 6 also must be a negative discriminant, because if there was a positive discriminant somewhere in here, let's say that there's a positive discriminant right here. There's not, but let's say there is, okay? If there's a positive discriminant here, then that means that in between this negative part and the 0 part, there needs to be another 0. And we know there's no more zeros. We know that the only zeros are going to be at 6 and negative 2. So we know that there is no positive discriminant in this range. So all the points here between negative 2 and 6 are negative discriminant points. Okay? And it turns out that all the points outside of this interval are positive discriminant points, and you can confirm that just by taking one number, like for example 10. If I try k equals 10, I know that it's 10 minus 6, which is 4, times 10 plus 2, which is 12. If I multiply those two together, I get a positive number. If the discriminant is positive here, it's also positive at every other point here greater than 6. Same thing with less than negative 2. If I just test one point here, that's enough to know that there's no other points less than negative 2, k equals negative 2, that are going to cause the discriminant to be negative. Okay? So our answer is this. If we wanted to write it in an inequality, we would say k is greater than negative 2, k is less than 6, okay? But if we wanted to write it in a number line, which is a sign diagram, we would do it like this, and we could even say, oh, it's negative here, okay? That's it.